Greetings to you, ladies and gentlemen. My name is Sulani Howard Malinga, and I'll be doing my report on Epanet. Safe drinking water, sanitation, and good hygiene are fundamental to human health, survival, growth, and development. As an engineering technologist, I have been given the task to make an analysis of a water supply project to be implemented by the GCB local municipality, intended to supply four townships in line with its water service development plan. So, Impronet hydraulic solver computer software was used in the design and simulation of the water distribution network. Epanet hydraulic solver software is based on the theory of Hazen-Williams equation and produces results that are in conformity with the simulation guideline. So, a water distribution system is a system of engineered hydrologic and hydraulic component which supplies water from the source to the required area. So these systems have to cater to the varying water demands and take place in a day, which is the highest during the day, as water is used for personal hygiene, cleaning, food preparation, and water clothes, while the water distribution is lowest during the night. So there are a few distribution system elements that are involved in a system network. So those elements such as pipes, tanks, reservoirs, valves, and pumps to make water available to the end user. So hydraulic infrastructure design for water analysis is intended to provide the water supply to four townships located within the Chisibe local municipality as mentioned in the executive summary. So as a appointed civil technologist, the aim of the project is to make an analysis of a water supply system to be implemented by the Chisibe local municipality. The design of the hydraulic infrastructure includes these components: the source, which is the Nyango River, water treatment plants, the Pastori Reservoir, two pumps, pipes, four demand centers, which are the townships, hydraulic profile for pumping mains, hydraulic profile for the gravity mains, evaluation of need for pressure and surge control. So moving on to the project brief, I just provided just the layout of the township. So we've also been given the average daily demand for each township, which for township number one is 70 liters per second, 75, 85, 145 uh, liters per second, respectively, to each township. So moving on to the literature review. So water is the source of life, of course. People depend on it for drinking, producing food, and maintaining basic standards of hygiene. So the Constitution of South Africa Act 108 of 1996 is, and specifically is its Bill of Rights, set out the basic right of access to sufficient water as well as a safe and healthy environment. Furthermore, the Constitution obliges water service providers to meet their constitutional responsibility of providing sufficient water services to the community. So the focus area. So the Chisibe local municipality is a small town in Vembe district municipality in the Limpopo province of South Africa, 39 kilometers southeast of Messina and 86 kilometers northeast of Louise. So the data compiled by the Statistics South Africa in 2011 suggests that the local population stood at 1052 people, according to census, with water inside dwelling at 8.2% according to census, and the rest of the local municipality water supply relies on river and dams. So we will just be looking at the Limpopo River Basin. So draining an area of approximately 408,000 kilometers squared, the Limpopo River Basin encapsulates a diverse landscape and four riparian countries Botswana, Mozambique, South Africa, and Zimbabwe. So, geology of the Limpopo. The Limpopo River Basin consists of 24 individual tributaries, 13 on the north bank and 11 on the south bank. So, the climate is perhaps the single most important driver with respect to determining the amount distribution to some extent, the availability of water in the environment, the temporal and spatial distribution of water, the intensity of preparation, and temperature of drive elements of the hydraulic cycle, and many other physical and chemical processes. So the water quality at a basin or some sub-basin scale, particularly in semi-arid and arid areas, priority is often placed on monitoring and managing of water quantity. So the sources of drinking water in South Africa. So provision of safe and affordable water remains a priority in South Africa, but its realization remains precarious. The country is committed to a policy of free basic water aimed at furnishing all poor households with a basic water supply, 25 liters per capita at no cost to the household. Moving on. So, how did I go about doing this whole presentation? So, you first download, of course, download your Epanet, uh, and then you do your project setup, which will be more clearer with pictures on my report. So first, select file, click new project button on the general toolbar. A new project is automatically created whenever Epanet first begins, and the screen appears to be like the one you find on my report. And you go to you set your project default. Step 3, you set your project view, set project dimensions. Step 5, you draw your system, following of course your layout that you've been given, and then you add your elevation respectively, and you add your pumps, your two pumps as described. You add the required total system duration, which was set 72 hours, and you step it by 4 hours in our case, and then you add the required adding the demand ratio. Add your pump diameters, which at first we're given 300 millimeters to start off with our diameter sizes, which gave us an errors and negative pressures, which is why we decided to increase our diameter sizes. And also we have been given also the storage required for a tank, which was 12-meter high, and its diameter was 34, sorry. And then after that, I then ran the system, which gave me errors, which I've described above, negative pressures, and also my velocities were higher than 1.5, which then I increased my revamp, which I then increased my pipe diameters, and also again I ran, which was then successful. So the resulting discussion. So I was given the storage required for a tank, which was 10,250 cubes. The fast storage property is 12-meter high times the 34-meter diameter. So as you can see, the volume that the storage tank can hold is 10,895.04 cubes, which is greater than the storage required for the tank. So calculated volume is greater than the storage required, therefore tank is sufficient and meets requirements. So now the table that I've just viewed in front of you is, since I think I forgot to mention that the task that is given to us clearly describes that the system must work 8 hours a day without pumping. So this in front of you shows you that you can see the two pumps are closed from o'clock to 8 o'clock, and the system is still. And now the second one, the system was set to continue pumping again at 9 o'clock, and I've opened my pumps. Moving on. So in front of you now is the profile height for all component from 12 o'clock to 8 o'clock when the pumps were closed, which still shows you that there is movement of water from the storage to demand center 4. Now, in front of you is the system flow balance. So system flow evaluation to check the need for surge control. Flow produced is higher than the flow consumed. This just shows that there is water available in the system and the water moves around and creates surge, which can potentially damage components of the systems, of course. And now, this is the hydraulic gravity mains for all components, which just shows you how the pressure is moving within our component. So in conclusion, the aim of this project was to provide water supply to the 4 townships in line with its water service development plan. Appointed by the Chisibe local municipality in Limpopo, as required, the system must supply water for 8 hours without pumping, which went successful. With a balanced system flow, which produces higher flow than the flow consumed, that means there is adequate water in the system. In conclusion, this means that the system run is successful and sufficient to be implemented.